The Doppler effect is something that you have to know for the MCAT, and this explanation is going to make it really easy. So we're starting in the top left up here. We have a wave machine, which is the square, and it's producing a wave traveling to that stick figure. I've colored each amplitude a different color just so we can track what happens through time. There is a 1 second difference between each amplitude, so in 1 second, the blue amplitude is going to reach the person. This row is showing us what happens after 1 second, and we see that blue amplitude has now reached the person. And if another second passed, the red amplitude would reach them, and so on. In the next two lines, the person is starting to move towards the wave machine. And in 1 second, the person goes from their original spot to this spot. As they were moving in that direction, the blue amplitude was still traveling towards them. All that taken together means that as they were moving, they passed by the blue amplitude and then reached the red amplitude. That means this person is passing by new amplitudes 2 times faster than the person was when they just stood there in the first scenario. And if you experience more amplitudes per second, that means that the frequency is increasing. So this person is experiencing a higher frequency despite the waves being the exact same. And your general rule here is that anytime you move towards a wave producer, such as a sound or a light producer, you're going to experience a higher frequency. You can experience this very easily with sirens on emergency vehicles because if they're traveling towards you, they sound higher pitched. In our next two lines, the person is traveling this way. The wave is the exact same, so once again, at 1 second, the blue wave travels from right here to over here. However, this time the person has moved from this spot to this spot. Notice how the person started in the middle of the blue amplitude, but since they were moving away from the wave, the red amplitude did not reach them after 1 second. So they experienced less amplitudes than normal. And that means that for this person, the frequency seemed lower than the frequency of the actual wave. And you can notice this as well with sounds because as something passes you, it's going to sound lower pitched as it moves away. In the scenarios on the right, the wave machine is moving this time. The first wave machine is producing a new amplitude every second, which is why there's a 1 second difference between each amplitude. And then the wave machine starts to move in the same direction that it's producing the wave. It's still producing amplitudes every second, but let's track this purple wave to understand what happens. After 1 second, the purple wave goes from that highlighted spot to this new spot right here. The wave machine, however, has moved forward, and at 1 second, it still produces that new amplitude. Together, that means that the new amplitude is going to be really close to that purple amplitude. What this means is that when something produces a wave and moves in the same direction that the wave travels, the wave actually has an increased frequency. We can see the exact opposite down here when the wave machine starts to move away from the direction that the wave travels. If we follow the red amplitude, we can see that after 1 second, it's over here. The wave machine is still producing an amplitude every second, but since it's traveling in this direction, it's going to be further away when that new amplitude comes out, which makes it appear stretched out like that. This means that anytime something moves away from the direction of the wave that it's producing, we're going to have a decreased frequency.